Good afternoon, guys. We'll see if we can get some folks in here and get this thing started. We're going to cover, I think, an interesting topic today. One that I've been meaning to cover for a while to make sure we had some pretty good understanding on the way mining pools work. And then when I start going down that, it starts to unravel all the other things that I probably should have to talk about when I start trying to explain how mining pools work and stuff. So we're going to let a few folks get in, and then we're going to go ahead and start this, and then you can obviously replay this on YouTube. So how's it going? Hope everybody's found their way over here. Let's go ahead and get into this. So what started this is I've had a lot of people reach out over probably the last year and a half on trying to understand on how mining pools function. You know, you set your rigs up, if you're renting hash power and you're pointing to a pool, you have different payout strategies, you have different, fees that are associated with that. And then, a lot of people are like, am I getting my proportional share? They may not understand on how things work with a pool. They hear a lot of words around centralization of mining power and all that kind of stuff. And we want to help try to demystify that. And the best way I can do that is articulate it kind of with a picture. And what we'll do today is we'll add to this picture. We'll make some adjustments. I'll take some of your guys' feedback, the folks that come in. That way we can have a pretty clear and concise depiction of it. And then that gives us a good baseline to have a proper educational video put up for it, to where we can come in there with some infographics and that sort of thing. That kind of lay it out. So I'm going to go ahead and get started. I'm going to switch over to the computer screen, and then we're going to go through essentially a draw.io diagram that I've kind of started, which will articulate the entire situation in general for a cryptocurrency, solution. This can be taken in the context of Bitcoin. It could be taken in the context of Ethereum, any proof of work mining aspect. Just proof of work mining, I haven't got into explaining on how hybrid proof of stake with mining, by and large it's the same, but there's some other details with when you have hybrid checkpoints in place that kind of go against some of the stuff that I'll be covering. But this is mainly proof of work. I use some Bitcoin references as this as an example. And then we can get into the details as we start to pull it back. So I'm going to walk everybody through right now, kind of getting into that, making sure everybody can hear me and everything sounds good. Looks like we have a few people in, so I think you guys would be yelling at me if you guys could not hear me. I don't do a ton of them on YouTube. Most of the stuff's on Twitch, but let's get into this. So this is a diagram I tweeted out earlier. I started kind of putting this together, and we're going to make some adjustments to it. I'm going to zoom in, so don't worry. But when we start trying to explain the way pools work in general, and then the different payout schemas that come with those, you have to start to understand the entire ecosystem to understand kind of, one, what makes probably sense for you, and then two, how these kind of work together and how the centralization aspects come into, cryptocurrencies in general. Because a lot of people have this misnomer that it's just about the centralized farmers. And in reality, it comes more down to where they send in all their hash power. So your centralization really happens at your mining pool standpoint. And then the business rules that are predicated on a mining pool can really, set forth a path of, is there selfish mining going on, all that sorts of things. So we're going to get into this one right now just from a concept of how things work. And then maybe if people want a more detailed kind of pipeline video of like how mechanically things work, with the math that goes into it, we can get into that. But I'm going to try to keep this one at a higher level. So here's your basic overview in general on the cryptocurrency space. It's going to be kind of rudimentary to start, and then we can move up. You essentially have your mining from your proof of work side, and it's really bucketed into three classifications here. You have your decentralized miners, which will be like anybody that goes out and purchases a miner and plugs it into a permissionless network. You configure it, and then you start mining for that particular network. you're essentially what you would be considered a decentralized miner. You own that hash power, and where you point it, you have a choice. You have a choice to send it to, any n number of mining pools that are out there, and we'll get into why you would choose one over another here in a second. But you would classify into that decentralized component in proof of work mining, and that could be through Bitcoin, it could be through Dash, it could be through anything that's doing proof of work mining. Then you have your centralized farmers, which are more kind of a collection of, the larger, conglomerates that have a lot of hash power, that are more dedicated, and their amount of combined hash power is a significant portion of certain networks, right? So, you could consider the BBT crew having, a partial centralized amount of farming power, but in the grand scheme of things, compared to most larger operations, 2,500 GPU as part of our BBT crew is small by comparison, but it's definitely questionable with the size compared to like a decentralized particular miner. Like it's a more of a centralized source of hash power that could then get pointed to different pools and whatever. Then you have your cloud farms, which this one kind of off to the side it's essentially the same as centralized farms here, with a centralized cluster of a hash power. However, you have this kind of broker. You have these serving as kind of a broker agent, where this kind of stuff here can happen, where you have a person that wants to pay for a service. We're going to copy this here. We're going to be editing this document as we go, because I'm going to make this available for you guys. So you have pretty much an agent system here, kind of like a pay-per-service, where you want to pay for hash power, and you will receive essentially a discounted amount of cryptocurrency, because you're going to pay minus fees, essentially. So there's a lot less overhead. You do not have the CapEx part of this. All the CapEx and OpEx is part of the farm, that the cloud farm that owns this, but you will pay a nested cost for participating in this. This usually is not the best margin play, obviously, because you're essentially paying this CapEx and OpEx cost as part of your service fee to receive this, but you are essentially paying for this to receive currency directly. Why this matters is if you are trying to get currency from the essential creation portion, and you are going to a particular address directly to yourself, you're getting it not necessarily in the payment channel gateways, which would be kind of up here, where if like you had this instance where you were buying something from Coinbase and you just wanted currency, you're essentially doing this operation up here. I don't need to actually copy that, to where Bob is buying to Alice, right? So if Alice is Coinbase and you're a participant just trying to buy cryptocurrency, you're up here where you're just broadcasting a transaction, and all this stuff's happening below, right? You don't care. You're just getting cryptocurrency. So in that case, you can either get it directly, or you can, where you're just buying it already from a mined coin and you're just purchasing up there, or you can get it at the inception down here. But again, just from the classification, I wanted to make sure I had the full scope of people that were mining. So these are the inputs into the system, and they effectively hold up and do a lot of they do all the validation, they do all the propagation of new blocks. That's what the mining community does. And those are the three kind of zones of it. Now we get into mining pools. So why do people go to pools? Well, you had the option in the beginning to do solo mining, which essentially you are pointing your miner to the network, and you are taking a chance at this little purple box here. This little purple box is going to be kind of the theme that we're going to go through a couple times here, of you are looking for a solution. So the way the ledger works is essentially a posted block. Once it's been confirmed and done, all the transactions set in these blocks. When a new block is getting ready to get minted, essentially that template comes out, and with that is a problem that needs to be solved. All of the hash power down here of the respective network, and if you were solo mining or you were trying to pool all your hash power, you are effectively trying to solve that solution. Everybody's working on the same exact problem at the same exact time, essentially. And they're essentially, it's like a number line here. I've seen a few depictions of this before. I like this approach of explaining it to people, but it's essentially like one long flat number line. And what you're looking for is that red dot there. And everybody works on a little capacity of this as much as they can, where, let's make this a transparent box and I'll show you kind of what I mean by working on the difficulty of the different difficulties that you can work when you're mining. Is you're going to get a sub portion of essentially tickets or a chance to try to solve that red solution there. You're trying to find that to be able to get the right to mint this new block right here. So the essentially what that means is here, let me bring this over here. I think it's this little guy here. That way we have this depiction here. Let's go with choosing the transparency here because I want that box transparent. And what I want to do here is when you're working on a part of a solution, essentially you are submitting a set of shares for, like, let's say that spot. And then you're working that, you're sending in X in amount of hashes you can, and you're trying to solve against that. And then what happens is one of those lucky miners down there get a work package that has the actual nonce that you need to find. A nonce is essentially just a single unit and proportional against, it's just one. There's one key that I'm trying to find here. And that work package that your miner starts to pick up and work, it ends up having that in its scope. So it submits and says, hey, I think I found it. And it broadcasts that to the network. And then that network agrees to that. And then it mints this new block that goes into the public ledger. The whole time you're trying to work that solution and that problem, you're also validating any kind of transactions that are going on in the network. Those set into a memory pool, and then those get posted the moment this guy's found. So it's whatever happens over this time period, and then it's posted. With blockchain or with Bitcoin, this is a 10-minute process. Mathematically, it's calculated. The difficulty of this problem is predicated on how much hash power is coming into the system. Now, that changes with certain different blockchains have different times that changes the difficulty of this problem, and it's not necessarily always on every block predicated on the hash power. On Bitcoin, it's after so many blocks. For some currencies, it's after every block. There is a variation in the business rules on different cryptocurrencies, but by and large, this is the functionality of the way this is occurring. So we're all working to solve this solution to then post that next block. And for that activity, we are rewarded in the block payout. So for like Bitcoin right now, it's 12.5 Bitcoin plus any transaction fees that were included in this block, right? So you get the transaction fees, which are pretty nominal right now, plus the reward, and then that's distributed back down to the miners that were part of that. Now this is where the pools come in. Since this problem is infinitely complex based on the amount of net hash, or the total gross hash power that's coming from all of these entities down here, that it's a simple math problem of figuring out what's your probability of finding this answer to this solution. It's exponentially in the amount of hash power that's required to have even a probability chance at finding this. Right? So this is where the pooling starts to come into. So it's a whole math problem of figuring out, like, okay, can I point my hash power to a function that will share all of this? So what the pools do, and we're going to get into a little more detail here. I'm going to bring up some different depictions of how this works, where you are going through and essentially giving your hash power to the pool with the cryptographic guarantee that you're going to get paid a proportional amount. Now that's what happens in theory with and what we'll do is we'll go through anytime you take a hop or a step on a process, there's always a chance for somebody to do something to it. So that's your first kind of indicator that, can anything happen between this step of the mechanical operation of a miner trying to solve this solution if I have something in the middle, right? So this solution here, you have an opportunity to go straight to just solo mine you have essentially, you connect essentially to the appropriate coin's daemon, and then you are trying to solve directly. That's infinitely complex, and there's a probability that you will never solve a block doing that. So you're effectively forced to go into a pooling of your hash power. And this is when it comes down to, like, how can you verify that a pool is being an honest player? Well, they produce essentially how long a round is, and you can verify how often a pool gets a particular block. Now, you only see with what they essentially can present to you, so you do have to take, there is a risk of, like, any pool could technically game the system if they gave you a false front line, if they weren't being honest with how much, hash power they actually had. However, by and large, people that have this much capex and this much, opex expenditures in there is a quite a bit of research that goes into just seeing if somebody's trying to game this system, right? And a lot of that stuff will come out on, like, Bitcoin Talk. It'll come out on the different sources of people saying, hey, I see something a little fishy here. My payout cycles are weird. There's issues with this whole PPLNS, where pays per last shares. So these things are essentially algorithmic ways to calculate shares. Shares actually denote a mechanical math. It's an algorithm essentially of what the difficulty of the solution is, or the difficulty of the problem is, and then how much the net hash that's coming into the pool. So a lot of this you can start to reverse calculate to figure out, if you sat down and did the time based on what the pool was presenting, you could get back with a pretty high probability if they're gaming the system or not, is what I'm coming down to. That being said, do a lot of people do that? It's an open question, right? What I'm just trying to tell you is that anytime you have a hop like this, you do have an option that there could be somebody gaming it. Now, there's different approaches to pools to try to circumvent that or de-incentivize that type of activity, which is like P2Pool. So if we look at, like, P2Pool, there's you take essentially some of that risk away from you put a lot more of the risk on the pool and not so much for the participant, because essentially as part of your hash power submission, you are guaranteed your portion mathematically. However, most of the time you don't have a lot of people that go over to these pools, unfortunately. Like in Feathercoin, like 3 years ago, P2Pool was kind of the more popular pool to go to because there wasn't a lot of people running mining pool software. And it worked very well, and I felt that I was getting my proportional share. I would say most of your major pool operators right now, Nanopool, Supernova, from a GPU mining pool standpoint, and even X11 and some of the ASIC pools, I mean, by and large have a decent reputation with regards to ensuring that the statistics of what they're presenting on their pool front page is mathematically, you can calculate that back to say, okay, they're doing, your pay per share, and on the last round, we'll get into PPLNS, what that is, but you could calculate that they're minus their fee, that it's pretty much bang on of what you've submitted based on your hash power and based on what that calculated into a round share depiction of how many shares you submitted in that round versus how many proportionally were submitted. That's reported on the page. So it's been pretty accurate. But what I wanted to make sure is to let everybody know that it's not, a full, fail safe that a pool couldn't try to game that. It's just part of it. And that's just the mechanics of making sure that the solution that's awarded is paid out to the pool, and then the pool pays out all the participants based on their share counts. You have that whole piece. So you can verify, hey, they received this many blocks, and this many blocks, and then you had a payout of X, right? You could figure out what's their pool luck based on how much they're having, how many blocks they've had. Now, the other part, and I see a super chat that came in about F2 pool mining empty blocks. Now, this is where it comes down to the business rules of what's submitted. And this is where the game in general, and that really bring in awareness. And when I talk publicly outside of, just normal cryptocurrency mining, when I try to explain to, the businesses that I work with and, government and other people that I talk to, when I talk about decentralization of mining and just mining in general, proof of work, and, the difference of centralization and such, all comes down to, you can have a whole bunch of decentralized miners, but if they're all using centralized pools, the pools have a lot of power and control to where they can change the business rules of what blocks they include and what they don't. We essentially, when we're signing up for a pool and we're sending hash power, we're agreeing to a block template, essentially, of what's being submitted. So if, to the question that was asked in the super chat, if the pool is setting the business rules of what we're getting as the work that we're working on and what's going to be included and not, that there is that option. They can also they can set in that block template the fact that they're mining, what is thought to be the current chain, but could be a selfish mining, to where they're winning blocks and not broadcasting them. They have, when you are sending your hash power to a pool, you have that option to be quote unquote gamed. We've seen this with Dwarf Pool a while back, where there was some questionable activity going on with Dwarf Pool. And it just comes out with the community calling out when they see certain things happening, certain behavior. Because ultimately, this entity and these entities down here, especially if you're decentralized, if you're just you bought your own hardware, you have a choice of where you're going. So staying spatially aware, you as a miner have essentially your own. If it's advantageous on the money and the capex and the opex that you spend, that you know where your hash power is going and you have a basic up-to-date understanding of what the rules that they're playing by. If somebody comes out and has done the due diligence to see that they are, they have submitted, they're not just taking the what's in the mempool and putting all that as part of the solution, part of that included in the solution, and then submitting it for the next block, and they're censoring transactions on the blocks that they win. Because mind you, all this comes down to is if on these different blocks, if block 818 was won by, let's say, Supernova, and then block 819 was done by Dwarf Pool, and if Dwarf Pool had a set of different rules that it was going to include, such as don't censor transactions from, these participating addresses, of whoever these participants are, they could have that to where when they go to include that block, they don't include those as part of that block, right? And you have those kind of activities because we've created a layer here to centralize hash power to have a better chance to get a proportional amount of all the block rewards, essentially. So this is why, this group down here tries to spread out or not spread out as much, and take a chance at, a pool with close to 50% of the hash power, because you want a 50% chance on every block. That's measurable. That's because of how much output that comes down to. And therein lies part of the problem in general of, what's the total output of a cryptocurrency network, relative to, its output. So if like Bitcoin, it's measurable every 10 minutes, as long as the hash power stays pretty in line with the difficulty is, before a difficulty adjustment, that block time stays within 10 minutes, 12.5 Bitcoin come out plus a little bit of transactions. You can figure out of what your proportional share, if a pool is winning 40% of those blocks and its luck percentage is 100%, meaning it's getting proportionally the output that it should, then you can measure that. And that's, if you have a pool that has 40% and the rest of them have 12%, there's a pretty high chance that you're going to want a more active payout, because you don't have to wait now an hour for a payout. Proportionally, it comes down to however much hash power you're putting out there, you're getting paid back, because you're getting the the lion's share, if you're a participant on that pool, and let's say you had to wait for an entire hour because you only had 20% of the mining power of that particular block. If there's only 20%, then you're getting a larger size of pie, by and large. So whenever you get that payout, you're going to get a higher proportion than, let's say, a pool that had 50%. But the issue remains that it comes down to how often is a pool getting a payout, right? And that's what it comes down to. And a lot of people, the behavior that has been witnessed across Bitcoin and across all the other cryptocurrencies is that, agnostic to the output of this, people choose pools that have a proportionally high amount of share of that mining hash power. And with that, you have the risk that I was just talking about. Now, again, by and large, I mean, I'm giving you kind of it open that they have the option to do those things. It's up to us to keep the pool operators as honest brokers, and call out when mathematically it's not making sense, right? When something looks off, and it's these PPLNS, which will bring up an example of PPLNS here. Let's do it here. So essentially, pay per last shares. I put all these links underneath. This is from the wiki. Is proportional to the miner's reward calculated in basis shares instead of all shares in the last round. So what it's saying is, if a round, like let's say on Bitcoin, if we use Bitcoin, or if we even use something like Ravencoin where it's 1 minute, you are essentially earning shares proportionally to the amount of total on the pool. And here, let me go back to this. And you are going to be paid out proportionally to the amount of output that you had. So if you had 1% or 2% into that, you should be able to calculate how many shares that you submitted in that last round. The reason why the last round is versus pay per share is that there's behavior that can happen where people kind of pool jump and try to submit a little bit of rounds on each pool and are trying to game to be part of the last round. So if you're hedging your weight across multiple pools that are on the same type of cryptocurrency, because they may all be splitting their luck, right? So you're trying to get a little bit of from any pool that wins. So there's a strategy to actually go through and try to get shares submitted on each pool that's part of each crypto. That's part of each. Like if we're talking Ethereum, and you're submitting shares across the top 5 pools, that you would get a proportional payout of what you've submitted. You'd be guaranteed on every payout, every block that was awarded, assuming that those top, let's say 5 mining pools, one of those top 5 won the next block, right? You would be guaranteed to be on every block essentially. So there's an activity, PPLNS is, it rewards the people that stay part of the round and then at the latest part of the rounds, right? So you're paid out proportional. So it's made to try to keep you and try to keep down the pool jumpers essentially. You have zero variance solo mining, where you have PPLNS is the way to go. I've always had very good luck with PPLNS. Then you have essentially zero variance solo mining. Zero variance solo mining is essentially what you see with like ETH pool, where each share submitted will increase the total credit. It sums up the total credit, and you have essentially this total credit that accumulates to where you frog leap over the next number 1 position. So if you technically did this for X amount of time, you would essentially walk this list all the way to the top to when the pool wins the next block, you get that reward. That process, that zero variance solo mining, was always pretty cool back in the day, when there wasn't a ton of hash power. However, they made a change here that I don't think really set well with a lot of people, where it was saying essentially any uncles found by the pool will be awarded to a random active miner. That was a huge change, in my opinion, for this pool, because what that meant is essentially for Ethereum that pays out uncles, or Ethereum pays out 3 Ether. When I used to mine on this, it used to pay out 5 Ether, and you'd win an uncle that would give you another 3.5 Ether. Well, if you came up to your number 1 spot and then that next block happened to have an uncle, you got paid your block reward plus the uncle. So that was like you got 8 Ether for your block attempt, which really was an extra bonus, right? Where now any uncles that hit the network go to randomly anybody that's actively running on this network. So what's happening here is you have people that can do this where I pull up this example here from May 2018 where somebody put out about 7,500 miners between 2 to 5 mega hash. So somebody, essentially what they're doing here, this behavior here is to get a high chance count and just work the probability. If there's 14,000 miners out there and the pool's business rules, this is where I'm coming back down to the pool's business rules. You could have somebody game this system where they have a high chance to win the uncle. So essentially you could be mining with 2 mega hash and win 1.4 ETH for 2 mega hash on every time an uncle shows up on that pool. So what they're looking at is trying to, or the community here was coming together saying, you should only do this with people that have a high amount of credit, at least, in the top, 100 or something that have been mining, have put the committal of, time. Some of these people that, have, like, look at this, like this guy, 219 mega hash. I'm betting that this participant here, if that's all his hash power, that's a single rig, right? And he's about to win in 2 days a full block, right? 3 ETH. That guy's probably been mining for 7 months to earn that full ETH, right? So, that's what it comes down to is the business rules matter on the pools. It's not just about the payment schema. You do have that situation where you have different other rules to these. And then again, you have, I put the P2 pool in here. This is considered, these are all mining pools, types of payouts. You got mining pools and then the types of payouts that come with a mining pool. Then you have a different type of mining pool. And then you have solo mining, which is just you've either forked an existing pool software just to maintain some kind of order and control of your farm. And I put this GitHub in the in the description where it shows like some just common mining pool software that's out there that's open source. What platform types they're on, what the pros and cons, what those were. YIMP I know has had some issues, and some some of the larger pool hacks have been on YIMP. Where there's maybe some issues here with that, so I'd be careful on YIMP. But that you could take this and you could try to solo mine yourself, right? To where you're not participating on, you set the business rules, and that's where you also get a lot of potential issues with people trying to do their own potential gaming of the mining, where they're doing selfish mining and such. But, this is a question that comes up a lot, and, people are like, well, how do I know that the mining pool isn't cheating? Well, part of that block template, what this comes down to, and this was said pretty well here on CaptainAllcoin.com, is essentially when the block template is created, the combination in this particular use case, they're showing that they're paying out based on a Coinbase transaction. So the pool essentially takes your hash power, wins. If it wins a block, it's paid to its wallet, but it's automatically generating as part of that activity reward back to your payout address on the pool, essentially. So essentially, they can't steal your reward by having that all kind of wired up that way, to where it's not about the mechanics of the automation of trying to game the the activity of when mining hash power is going to the pool, trying to solve this solution. All of that's very mechanical. It needs to be super mechanical just because of what's going on with the solution finding. But it all comes down to, once that reward is done, how does the 3%, if that pool takes 3%, come off? What is the submitted share count? Is the mining software you're using, the pool that you're using, reporting back the right information? Is what it comes down to. Yeah, and smaller pools have been known to overnight. So one of the good statements in the chat is also like, you know, when you're mining, when you're giving your hash power to a pool, that goes out and pays you into a wallet that you usually have with the pool, right? So let's just put a little thing here, call this wallet, and it's very advantageous to try to get that out of, you know, whatever you have a wallet payout address. So the pool wins. This is your user wallet. Let's call it user. Right. And then the pool will pay. Let's take this down. Let's delete that. The pool gets paid for taking your, you know, submitting essentially the solutions. They're channeling the solution, and as part of the block template, when you're getting work from the pool, this is essentially how this works. The pool wallet, right? So the mining pool issues you a work package. You work that work package. When you're submitting that, as part of the wiring of that is trying to produce the solution. It's saying that, hey, I'm giving you essentially a portion. This is a work package, right? The pool is sending you a work package, and it's giving you essentially your work package that you're working, and you're submitting sets of shares. That work is your proof of work, right? That if it falls within that box, it falls within finding the nonce, and it says, "Oh, I found it." That's all submitted as the solution. It's then projected to create essentially the, you know, on the ledger. It broadcasts that as a valid block. It includes transactions and all that. The payment reward that occurs, let's just do something that looks cool. It's a payment reward. Diamonds are always cool. Let's say reward. And let's use Bitcoin for this particular instance, which I know is kind of interesting considering this channel is mostly non-Bitcoin mining. It's all other mining, but we'll go with it. So it's the reward of 12.5 plus transactions. Plus the transaction fees, right? That's what's the reward from solving that solution, is then paid back to the pool's wallet, right? Because this is found. That also then, you know, clarifies this to be good. You know, that's now good to go. Change the color on that, and they're rewarded. Now the pool, based on that PPLNS, if this is what they're using, will broadcast. Well, internally, we'll say, okay, now pay. Here's their shares, and then here's the amount that's owed to you. All that stuff's happening mechanically in the background, right? Now the pool is going to give a dashboard, and it's going to estimate on a few different figures, right? The pool's estimating on its own pool's proportional hash versus difficulty, and then luck. So it's doing a couple calculations to try to figure out essentially the same thing of what a mining calculator does, and then it's taken in the luck. And then it's doing also fees. Most of the time they don't include the fees, I noticed, in the dashboard. It's just kind of a thing that happens after the fact. It's kind of like taxes. It just kind of happens. But this is effectively what the pool's doing, is it's doing these actions separately. So then it gives you a dashboard to kind of figure out what your expected output and return is, and this your essentially plan versus actual is what it's coming down to. But then that pays out to your user wallet, right? And then you can figure out if that makes sense or not. But that's effectively, I mean, if we did this, 8 months ago, 10 months ago, there'd be a lot other, there's other options there of, a lot of these other solutions are not really used. PPS isn't really, most of all of it's all PPLNS, or it's a zero variance solo mine. Mainly because of the risk of, the pool, either overpaying or over predicting, and then not linking your mechanical amount of how much you've shared, you've submitted as a participant versus what it's earned. You have that kind of an issue. I mean, the SMPPS, which is just, it pays per share, but it wasn't on the last share, so you had a lot of people that were moving pools a lot. So it was essentially taking this, but it was with this extra little added feature where it would never pay more than it earned. Because essentially the payment and the amount are usually different, different wallets. Like they'll get the pool will get a reward, but it's paying you out of a different wallet. Some of that's for OPSEC reasons, because they don't want to have a risk of a lot of, currency available on a hot wallet. There's some mechanical reasons why they would do that. But some of these other mining pool things that you don't see too much, and the geometric method, generalized double geometric method. I mean, a lot of this is just essentially the round math that's occurring to validate the amount of shares and then to do the probability. So this is essentially the algorithm that's going on in the background to automate all that. There's not some person in the background just trying to manually push out payouts. It's doing it mathematically. But it all comes down again to the things that are happening mechanically, and then the things that can happen with, the business rules. I'm going to take some questions and then we'll wrap this one up. I mean, I'm going to make this available. I'm going to put this out. If you guys would like this image, I think that we can add more to it. I want to add a few more things to it. I think the broker services thing can be added a little more detail here, where people like to see this part of the stack, where like NiceHash comes from. NiceHash is essentially a broker service. So people are like, these guys are like, you know what? I'm tired of just trying to mine my own pool stuff. I'm going to sell my hash power, take my hash power and sell that to a broker. And I'm going to find a counterparty that's going to buy that. And then they can force project. This person gets to set up what pool they want to go to, or if they want to buy up everything and go directly for this solution, and then they can go right after the network itself, right? Versus going through a pool. They can essentially solo mine. And that's where you could go into these whole kind of situations where somebody could come out of NiceHash and go into a custom script that is trying to do something malicious, such as double spend, to where you can have malicious scripts that's running their own pool plus new rules, such as transaction censorship. Right, to where they can buy the hash power that's required. Effectively, they're doing their own mining pool, and then they're submitting with everybody else on the same solution, because they're just downloading the work problem just like everybody else, and they're doing it in that fashion, right? That's the other thing that can occur here, with malicious actors, anyways. That thing's not really wanting to play out, but that's weaponizing essentially the hash power, because there's a broker service. Essentially, it's nothing that's not, NiceHash, places like that will catch a lot of hell, but in reality, it's weaponizing their service, essentially, is what it comes down to. It's, that's probably not, obviously not their intent when they made it, but then it's weaponized. can you explain more about P2 pool? Yeah, so let's bring up P2 pool, and then So we'll essentially go through the basics of what's going on. So essentially, the P2 pool is creating it creates a new blockchain. It's considered a side chain. And then what it does is it allows the lower difficult target. So you have to answer what you have to do to understand why this has to occur is what the mining pool is doing. A traditional mining pool software is it's creating these work packages for you, right? It's allowing you to have a target difficulty because this is a complex problem, right? Like of a whole network, you got to find this one solution, this one little nonce in this complex problem, right? Is that screen big enough? You guys can see that. I don't know if you guys can see that or not. Let me bring up the view here, because this is kind of a key point of why these pools are different and why you have to do things. You guys can probably see that. So that you're getting these work packages, right? And like if you only have one rig, like let's say this is the Ravencoin network and it's at 5 terahashes of output, and the difficulties 3 terahashes of difficulty. Let's just figure out some numbers, right? That it's infinitely complex. Well, if you have a mining rig that's 50 megahash, 50 million hashes per second, and you have a total network of 3,000 terahashes, right? Like 30,000% higher, right? Your chance of finding that is next to none, right? It's not going to happen. So what you do is you're going to get this entire solution, just like everybody else. This entire solution is essentially what's being asked for in this proof of work to validate and mint the next block. So you're going to work on a sub portion of that problem. You're going to get a work package from a pool that says, you know what, you don't have that much hash power, but just with the hash power you do have, just look in this range, and then submit back the work. And then you're going to get a share count for that, proportional to whatever the difficulty is. And you're going to get a accumulation of shares of all the different work. So like each time I pick up and drop this is essentially like your miner picking up and doing different things. And this number line is infinitely huge, and you're trying to find a grain of sand on it essentially. And then you get a work package that has the right nonce in it. That's effectively what's going on in the most easiest way I can explain it to you. And then you're going to get that. Your miner's going to figure it out, and it's going to submit it and say, hey, I found it. And it's going to broadcast it, and the rest of the network's going to agree because mathematically it's going to say, yep, this dude found the answer, right? Well, from a mining pool, it's going to give you that work package, and embedded in that, it's going to include essentially it's like a shell, like a template. That way, the mining pool gets the reward sent to their address, right? It's saying on behalf of the network, I'm working all this work in the background, and I am submitting this one work package to the network. To do that on a P2P pool, to where you don't necessarily have that type of activity, you're still going to get essentially the work package just in a different way. You're going to get it done through a side chain. So you got what this is exactly saying is the blocks you get in the P2 blockchain or a share chain, the same blocks that you would get in in this case, this is a Bitcoin blockchain, but it'll only have a lower difficulty target. When the peer announces a new share is found, the new block P2P chain is received by the other peers, and those peers verify that it contains the block payouts for all the previous miners that who were on that share. So essentially, it's just an effective way to do this activity. Keep going back here. It's effectively a way to do this kind of activity, just not through a work package, but doing it through a side chain. So you're getting essentially a spun up side chain of getting that kind of activity and then being able to submit to it. But again, as part of that template, if somebody was trying to game this, the activity that creates those side changes where you could get into that censorship and stuff. So if the block template itself, if the behavior that's been set up by the pooling services has some other kind of malicious intent to like do other stuff, then the template and the sidechain you're working is no different than what a pool would be doing if it's business rules of the work package it was sending you. That's effectively without getting into the details of the math that's going on and how to have a sub list of how that chain will work. That's the best way I could explain it. So you could have that same kind of thing. It's just a different way to distribute the work using a different methodology than a pool trying to keep a list, and then issue out, work packages. I don't know if that helped or not. And I mean, so part of this exercise here today was to kind of go through this, help vet some of this document out with you guys, like kind of go through and see how receptive this kind of documentation looks, and then turn this into essentially a motion graphic video to where it's like 3 to 5 minutes that explains mechanically through some automation of the imagery to show, hey, you as a participant, are submitting it to a pool, and then here's how the basic mechanics work in general. I don't know. I mean, I don't know if that would help folks understand it better, but the part of the whole reason of why people should even care about this is if you're these people up here and you're like, dude, I know a lot of stuff goes down in the background. Like I just want to buy some Bitcoin and I want to hold, or I want to go out and I want to do stuff with it. I know there's a lot of stuff that goes into it, and I can go out here and I can look and see my stuff happen here. But to understand what's going on in the bottom here of the other participants is to then start to understand more deeper conversations when we start talking about centralization of mining and stuff. Because what ends up happening is your real big centralization stuff is happening here. And it's done behaviorally because we all want a higher chance at getting a proportional share of that block reward, right? So we create these buckets that we get into to try to get a more a higher frequency of that proportional share. So the behavior really comes down to changing potentially this activity here to where part of the reward system is like some kind of rolling wave, or I trust me, I've tried to think about this a lot to see how could you incentivize a more higher distribution, and it always comes back to where everybody understands that 51% is always considered bad. Even if you had a good actor in the pool, all the 51% does is it does open up the option to potentially cause an issue to where if you had a script to come back in here, you have the longest chain. You have more than 51% of the network. Thereby, you could create a situation where you are including or not including particular transactions and undermining the entire way the blockchain functions from a posting of transactions. So most of the communities try to stay with under that 51%. But if you're close to 50 and if 51's bad and you're at 40 to 45, then proportionally with PPLNS, and if you're a participant down here, you can calculate essentially what your payouts should be as long as they're maintaining close to that 40%. And that's why you see a lot of current mining, like ETH mining, the pool mining and stuff, set anywhere from 41 to 47%. Carter, you think Andres having novels of mining, man? No, dude, I just, we get a lot of questions, and unfortunately I'm going to come off the screen. And yes, guys, I will put this right after this video. I will put a link underneath it. I'll put that diagram out there for you guys. And this is draw.io is what I'm using for this. It's free. It's an XML file, essentially, that you could import in, and then you could go in there and change it and all. So I'll make both the XML available, and I'll make it as an image so that if you want to use this or take it or whatever, it's all free for you guys to use. If you're using it for collegial stuff or you're trying to explain it to somebody, you have a school project or something, that's what it's for. It's open source, bros. So because if there's better ways to present it for people to understand, I think it's good, especially for people that are participants in the mining side. Again, I kept this very open. It wasn't just about GPU mining. It's, ASICs or anybody's, because it's all essentially the same thing. Proof of work is performing a function. And that function, you're paid in a reward. How that comes together with regards to payouts, pools, how to keep, pools honest, what's their business rules. So that separation, and I think really as I started to explain this out to you guys, I started taking mental notes of how else to maybe expand that mining box, and then explain, here's the things that are mechanical, where you have those algorithmic components where the block template gets transmitted to people. You have your share submission. All of that's very mechanical. That has to be mechanical. It's very hard to game that, and anybody that would create a pool to try to game that is risking a lot of different things, like it not working right, them having an incorrect payout for themselves. So a lot of that mechanics is very wired up well. It's the other things in business rules when you're submitting the block, essentially, of the other things that can happen from a business rule standpoint, like censoring transactions, like if you're just taking what's in the mempool and posting it, the sort order, essentially, the way most of that works is whoever pays a higher transaction fee is guaranteed to be included in a block. Well, if somebody had a censorship of an address, they could technically say, yeah, I don't care what you paid, you're not going to be in that block, right? If they had a known address. You have those type of situations, right? And then how that would work mechanically on the block template, breaking down the wiring on how the block template works from like a mining pool, and how does that manifest and look, when you get that, really breaking that down. I haven't seen any kind of diagramming of that out. I mean, you can't find it on the internet anyways. At least I haven't been able to. Carter draws like a boss. I've never seen Draw.io. Yeah, Draw.io is really good for these kind of things. It's free. You guys can download a local copy of it. It's like a cheap version of Visio, but it's got a lot of cool stuff in it. But it allows you to save things in XML, so then you can bring that up with all of its glory and all that kind of stuff. So, again, I wanted to try to keep this one to an hour. Hopefully, I don't know if this helped or hurt you guys, or if the visualization helped to kind of put it together and explaining on how things functions and work. I was more kind of explaining almost how cryptocurrency works more than kind of how the mining pool, thinking about it. I might have to change the title of this video and then put a little more time into the mining pools. But when it comes down to it, the math is pretty straightforward on that. It's more the business rules that we need to talk about. So I'm going to give it 3 more minutes, and you guys, if you guys have any questions, it's kind of that ask me side. If you guys want to, ask any questions about, this particular subject or any other things that you want to see in this as I make this post available to you guys. I'm watching the chat right now. If you guys have anything. And then, again, I'm going to post this. I'm going to actually save this right now as the way it is right now without making any changes to it. And then I will get that posted out to you guys. Start a PBS channel on crypto. Yeah. I don't know, man. There's, I value the guys that come in here and you guys come in here and watch and stuff, and offer, your comments and stuff and, share what you can. But I'm not very known in the space. I mean, if you look at any of the crypto, videos out there, or I wouldn't say influencers, but just in that crypto sphere and like I'm my own little thing. Like a lot of people don't know who I am on this. Yeah, so I'm gonna do Twitch later. I'm gonna do it tonight. So I will have more follow-up content maybe on this, but I was actually going to pull some hardware if you guys wanted to look at some hardware tonight. So on Twitch, BitsBeTrippin, we'll do some hardware stuff, but that won't be until probably after 8 or 9 tonight, Central Standard Time. And we'll get into some hardware stuff. There's some things I wanted to get put together. I just have some hardware here sitting here that I want to put back in a rig. I'm turning some rigs back on. DAG epochs, yes, we could get into that. That's essentially that's a whole conversation in its own. I could go into a whole thing. Let me write that as a detail for the DAG, because that's pertaining to Ethereum. Well, it's pertaining to a few different ones, but the DAG is an epoch level on a DAG is essentially a pointer in there, so we could go through some details on that. Maybe we'll get into that tonight. I have not seen any enhancements for the ETH enlargement pill for the RTX 2080 Ti's. All right, guys, I'm going to wrap this one up. And obviously, I can't send you anywhere because this is YouTube. So we don't raid other channels. So I will catch you guys later on follow me on Twitch and Twitter. And you'll see when I go live on there. And I'll catch you guys in a bit. Peace.